Hello, welcome back. Right now, what we're just going to do is correct that page 48. So you guys just did some problems on 48 with some scientific notation and really small numbers and using negative exponents. So remember, there are three things that I like to do. First thing that I like to do is get decimal placed, okay? Get decimal placed. And when we do that, remember, we want the number to be bigger than 1, but less than 10. Okay, so that's the first thing I'm going to do right now. I'm going to go put my decimal in so that I have a number bigger than 1 and less than 10. So when I put it in here, it's going to be between that 2 and the 8. Okay, so 2.8 is what I'm going to write. The second step is to write times 10. So you're going to write times 10. So I'm going to go in here and write times 10. And the third thing I'm going to do is start at the decimal I made, start at decimal I put in, and count how many places I moved it. So you count how many places it moved. Okay, so if you need to, go ahead and write this in your notes, but this is a summary of what we did. So I start at this, and I'm going to say 1, 2, 3, 4, 5. And remember, this is a really small number, so my exponent is going to be a negative 5. All right, so it's the same rules over and over and over again, whether you're talking about big numbers or small numbers. So I'm going to put my decimal in here, so it becomes 4.17. Bigger than 1, less than 10. Second step, write times 10. Okay, and I'm going to go find out how many places did I move that. 1, 2. That's a small number, so it is a negative exponent. All right, go put your decimal in. So I'm going to put it in here. So it's 1.5. Step 2, write times 10. Then how many places did I move the decimal? 1, 2, 3, 4, 5. Small number, so a negative 5 exponent. All right, number 8, now we're going to start the other way. So we are in scientific notation, so we just want to move that decimal how many places? Well, that number right there is a negative 6. So I'm going to move it left 6. Why? Because negative means small number. So I get smaller on my number line by going left. So I'm going to go around the 3. That's one place. So if I have the 3, 5, 8, 2, I'm at between the 3 and the 5, and I move it one place. Then I have to add my zeros in front this time because it's a smaller decimal. So I moved it 1. Here's 2, 3, 4, 5, 6. Then put your decimal in there. Okay, and remember, we're always going around that number 3, so the number of zeros is going to be 1 less. 1, 2, 3, 4, 5, 1 less than that 6. All right, number 10. So I have my 297. So I have to move the decimal here. It's a negative 2, so I'm going to go left 2 places. So I'm going to go 1 place around the 2, and that means I just need 1 0 because I'm only moving it 2 places. So I have the number 4. Notice I write the number over on the right because I know these are small, so my zeros are going to go in front. So if the decimal was here after the 4, I move it 1 place around it, then I have 2, 3, 4, 5 zeros, and put your decimal. That's a negative 5, so count 1, 2, 3, 4 zeros are in front of it. All right, number 14 says the mass of a proton is, write it in standard form. Holy buckets, look at that, it's a negative 24. So I have to move 1 place in front of that 1. So I move 1 place to get in front. So then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Holy buckets. Oh, I have to go to 24. 24 with that decimal. So right here, there should be 23 zeros. I believe there is a test question one time that comes up on your test on that's going to be coming up, and it's going to ask, how many zeros would you have? Well, when we're going back like this, we only have to go around 1, so it's going to be 23 zeros in here. All right, on the next page, what did we have to do over here? Number 20, oh, we had to do 16. So let's get 16 done. Alpaca, alpaca's right here. So we want to put this in scientific notation. So the first thing I do is put my decimal in here, 2.77. Second thing, right, times 10. Now how many places did I move that decimal? 1, 2, 3. That is a small number, so make sure you have a -3 for your exponent. All right, number 22 should be down here on the bottom. What measurement would least likely be written in scientific notation? Thickness of a dog hair. Well, that's not very thick. Like, think about a ruler. Would you ever say it's an inch, a quarter of inch? It's pretty small. The radius of a period on this page. So if we put a period, can you measure that with a ruler, like with a 1 inch, quarter inch, or is it smaller than all of that? Or the ounces of a cup of milk. Well, think about that. When you pour milk, don't they say you have a 6-ounce cup, an 8-ounce cup, a 12-ounce are in a can of soda? So I would say that the cup of milk is the one that we are not going to put in scientific notation because it's not really big and not really small. Not really small or big. It's a whole number. Okay. All right. From 22, we did number 23. All right. So here, what we are going to do is number 23. And in number 23, we are talking about the metric system. So if we're talking about meters, we then have deci and centi as our prefixes here. So we're going to start here at centimeters, and then they want us to go to meters. So if we have 7 centimeters, if we look here, there are 2 places between centi and meters. So centimeters are bigger, so it's going to have to get smaller to go from centi to meter. So we're going to take this decimal that's here at the end, and it's 2 places. So we're going to move it 1, 2 places, so it becomes 0.07 meters. Okay, so 0.07 meters. Now they want us to write this in scientific notation. So this to be in scientific notation is going to be, so it's already in a number between 1 and 10, so it's going to be 7. Then the second step is to write times 10. And remember, anything to the 0 power, which means we would be multiplying by 1. So this is really 7 times 1, which is 7. So we're going to have 7 times 10 to the 0. 0.07 meters, remember we have to have that first number. It's still going to be 7 times 10, but now how many places did we move that decimal? So if it's right here after the 7, we moved it 1, 2 places, and we're going to have a negative because that is a smaller number. So it's going to be 7 times 10 to the negative second. So they are differed by 2 decimal points here. All right, so after 23, we now have 27. Is that still on this page? 27. If you were asked to express the weight in ounces of a ladybug, would it be positive or negative? Well, is a ladybug going to weigh bigger or more than an ounce? Well, an ounce, ladybugs are pretty light. So this is going to be smaller, and because it's smaller, we're going to have a negative exponent. All right, and I think the last problem here that we were going to do was number 35. So analyze the relationships, write them from least to greatest. Since we're writing from least to greatest, I'm going to just make a number line here to make sure that we know that as we are -3, -2, -1, those numbers are smaller. So the further left we are on a number line, the smaller we are. So we are going to compare exponents. Compare exponents. And the smaller it is, the smaller the number is. So what do we have? A -2, a +2, negative 3, negative 2, negative 1. Well, let's look here. Negative 3 is the smallest one that I set up here. So we're going to start. This is going to be your smallest, 5.85 times 10 to the negative third. Then I think when I was going through these, we have a negative 2 and another one that has a negative 2. So the negative exponents are the same. So now we go to the numbers. And what is smaller, 1.5 or 2.3? Well, 1.5 is smaller, so that's going to be my next smallest number. And then the 2.3 is just a little bit bigger than that 1.5, so that is my next smallest. All right, negative 2, positive 2, use that, negative 1. So negative 1 is smaller than 2, comparing those exponents. So 9.6 times 10 to the negative 1, and the biggest number we have here is 1.2 times 10 to the second. All right, so when we're comparing scientific notation, you want to first compare exponents. Remember negatives, negative 3 is going to be smaller than negative 2, and then after that, we compare the coefficients. So when they were the same, the negative 2's were the same, then you just go ahead and compare the numbers. 1.5 is smaller than 2.3, so that number is going to be smaller. That should about wrap it up for correcting this assignment. So hope everything went well and we answered all of your questions.